Hi everyone, and welcome to this algorithm course. My name is Amelia, and I'm here to make complex concepts simple and fun. Today, we're diving into the fascinating world of sorting algorithms. In this video, we'll focus on three fundamental and widely used sorting algorithms: selection sort, merge sort, and quick sort. Let's jump in and explore why sorting is so important. First, let's talk about selection sort. This is a simple and intuitive algorithm. It works by dividing the array into two parts, a sorted section and an unsorted section. The algorithm repeatedly finds the smallest element in the unsorted section and places it at the beginning. This process continues until the entire array is sorted. Next, we have merge sort, a powerful divide and conquer algorithm. It works by recursively dividing the array into smaller subarrays until each subarray contains just one element. Then, it merges these sorted subarrays back together step by step, resulting in a fully sorted array. Finally, let's look at quick sort, another divide and conquer approach. This algorithm selects a pivot element from the array and partitions the other elements into two subarrays, one with elements smaller than the pivot and another with elements larger than the pivot. It then recursively sorts the subarrays, leading to a sorted array. Now, let's start with the selection sort. For a given array look like this, we're going to sort it in ascending order. Start with the first element, 64. Find the smallest element in the array, 11, and swap it with 64. Array after first pass, we got the array like this. Move to the second element, 25. Find the smallest element in the remaining array, 12, and swap it with 25. Array after second pass, we got the array like this. Repeat this for the third element, 25. Find the smallest element, 22, and swap. Array after third pass looks like this. Finally, we got the array fully sorted. Next, let's go through the merge sort. Let's use the same array. Firstly, we divide the array recursively. At each layer, we divide the unsorted array into two halves until each subarray contains one element. At the first layer, we pick 12 as the middle element, split it to two halves. At the second layer, we pick 25 as the middle element, split it to two halves, and pick the 22nd as the middle element, split it to two halves. At the third layer, we pick 64 as the middle element, split it to two halves. Finally, we have the single element in each subarrays. Next, we repeatedly merge the sorted subarray back together to produce a fully sorted array. Finally, let's move to quick sort. Let's use the same array. We pick the last element 11 in the array, make it as the pivot element. Partition the array so that elements smaller than 11 are on the left and larger than 11 are on the right. Once we found the partition position is at 64, we can swap it with the pivot element 11. Since the left subarray is empty, recursively apply quick sort to the right subarrays. At the second round, we pick the last element 64 in the array, make it as the pivot element. Partition the array so that elements smaller than 64 are on the left and larger than 64 are on the right. Once we found the partition position is at 64, we can swap it with the pivot element 64. At the third round, we pick the last element 22 in the array, make it as the pivot element. Partition the array so that elements smaller than 22 are on the left and larger than 22 are on the right. Continue the process until the entire array is sorted. These algorithms form the foundation of sorting in computer science and are critical for optimizing various real-world applications, from database management to search engines. Thank you for joining me on this journey. Don't forget to like, comment, and subscribe if you found this helpful. Stay tuned for more algorithm tutorials, and as always, keep learning and coding.